Find the equation of the tangent line for f of x equals x minus 2 times the cubed root of 6x squared plus 2 at the point x equals 1. To find the equation of the tangent line, we need the x and y coordinates of the point. Right now we have only the x coordinate, so let's find the corresponding y coordinate. And that's going to be found by plugging that x coordinate into the function. X minus 2 times the cubed root of 6x squared plus 2. So our y coordinate will be f of 1 minus 2, times the cubed root of 6 times 1 squared plus 2. 1 minus 2 is a negative 1, times the cubed root of 6 times 1 squared, which is a 1, and then plus the 2. So we have a negative 1 times the cubed root of 6 times 1 is a 6, and then plus 2. So negative 1 times the cubed root of 8, which is negative 1 times a 2, and negative 1 times a 2 will be a negative 2. So we have a y-coordinate of negative 2 paired off with the x-coordinate of 1. So we have the point 1 comma negative 2. The next thing we need is the slope of the tangent line, and that's the derivative. Now we have a product of two functions, so the derivative will involve the product rule. Before I actually take the derivative, let's rewrite the second expression as a fractional exponent. It's 6x squared plus 2 to the first power and third root. So there's the product rule we're going to be taking here for our derivative. F prime of x will be the derivative of the first function will just be a 1 times the second function left alone, so 6x squared plus a 2 to the 1/3 power, plus the first function left alone, so x minus 2, times the derivative of the second function. That'll be bring down the power 1/3, leave the inside alone, 6x squared plus 2, subtract 1 from the power, I will call it 3/3, and then multiply by the derivative of the inside, which will be a 12x, to complete the chain rule. Now we need to simplify this as far as needed to be able to plug in x equals 1. Our first term, 1 times 6x squared plus 2 to the 1/3, will just be 6x squared plus 2 to the 1/3. Our second term, all this other stuff, I'm going to put the constants together. I have a 1/3 and I have a 12. That'll be 12 over 3, which is going to reduce to a 4. I have an x right there. I'm going to put that out front. Then I have the x minus 2, and I have a 6x squared plus 2 to the 1 minus 3 negative 2/3 power. Before we plug in the x value of 1, we're going to want to rewrite all negative exponents as positive exponents. That's a guarantee. You don't have to simplify this as much as needed to write the function derivative, but you will need to simplify this enough to be able to plug in the x equals 1. And generally that means at least negative exponents need to move to the denominator. I'm going to move this 6x squared plus 2 to the denominator, so it's to the positive 2/3 power. At this point, we probably have it simplified enough to be able to plug in the x equals 1, so our slope is going to be f prime of 1. And that will be a 6 times 1 squared plus 2 to the 1/3 power plus 4 times 1 times 4 minus 2 over 6 times 1 squared plus 2 to the 2/3 power. 1 squared is 1, times a 6 is a 6, so we have a 6 plus 2 to the 1/3 power plus the numerator here will be 4 times 1, which is a 4, and then 4 minus 2 is a 2, over 6 times 1 squared, which is a 6, plus 2 to the 2/3 power. So our slope, or f prime of 1, will be 6 plus 2 is 8 to the 1/3 power, plus 4 times 2, which is 8, over 6 plus 2 is 8 to the 2/3 power. Now what 1/3 power means is cubed root. Cubed root of 8 is a 2. And we have an 8 divided by 2/3 power beats the cubed root of 8, which again is a 2, but then you square it. So we have 2 plus 8 divided by 2 squared, which is a 4. 8 divided by 4 is a 2, and we have 2 plus 2, or 4, for our slope. So we have the point and we have our slope. We can now set up the equation of our tangent line using the point-slope formula. Y minus dy coordinate, which is a -2, equals the slope that we just found, that's a 4, times x minus dx coordinate, that's a 1. Y minus a -2 is equivalent to y plus 2. Let's distribute the 4 in on the other side, 4x minus 4. We want to solve for y here, so we're going to subtract 2 from both sides. And that gives us the equation of the tangent line, y equals 4x minus 6.